Hello everyone, in the previous video we have seen the free oscillations. Now we will go ahead with the damped oscillations. Again we will take the same examples, that is simple pendulum and the spring. In this case what happens is this is sprayer which makes the to and fro motion when, because of the resistance present in the damped oscillation, it goes to this end and it comes back. Since we have a resistance here, it will not reach the same height. The height of the oscillation will decrease. When it goes to this side, the height will be reduced. Why? Because it has got the friction between the system and the air molecules or the medium. So it decreases its height. It decreases in the next cycle, again decreases. Ultimately, at the end, after some time, it stops to the mean position. This is the mean position and the sphere will stop here. This is the damping. The oscillations are damping. The same is with this spring and mass system. Say its amplitude is from center till here. This is the amplitude. It makes the up and down motion like this. When you pull it and leave it, it makes the up and down motion. But in the next cycle, the height will be reduced. And in the next cycle, the height will further reduce, and at the end it will stop at the mean position. At the end it will stop to the mean position. So what is happening here is the oscillations are damping, that is the amplitude is decreasing. Why? Because we have the friction involved in this, or the resistive force which is involved in this. So what are damped oscillations? Damped oscillations are the oscillations in which restoring force is present. With this restoring force we have resistive force, or it is called as the friction. Friction is present, and the amplitude will decrease. It decrease with respect to time. And the time of oscillations is finite. The definition of the damped oscillation should include these all points. We know that the restoring force, it has to be there. With that, the resistive force or the frictional force is present. Amplitude is constantly diminishing, or it is damping with respect to time, and time of oscillation is finite. After some time it is going to stop. Now we will see how the graph or the sine wave of the damped oscillation is. We know along the y-axis it is the displacement. Along the x-axis we will take it as the time, and then say this is the first oscillation, this is 2, and then this is through, this is first cycle. In the second cycle the height or the amplitude should decrease, so it will decrease little bit, and other side also it has been decreased. In the next cycle further it decreases, and then it decreases, and finally it will reaches to 0. It will become 0. So the amplitude is constantly decreasing, or it is damping. So the amplitude of the oscillations, it is damping. That's why it is called as damped oscillations. What are the examples of the damped oscillation? All the examples of the simple harmonic motion in which the resistive force is involved, so that it will terminate. The oscillations will end after some time. So examples are simple pendulum, a spring, or guitar, a tuning fork. All the examples in presence of the friction. Or when you take a ball, when we leave it down, it bounces and stops. After some time the height will decrease. The height of the ball will decrease and it will stop the bouncing after some time. So this is the these are the examples of the damped oscillations. In the next video we will discuss about the derivation of the damped oscillations. Thank you.